In any quantitative science, the terms relative change and relative difference are used to compare two quantities while taking into account the sizes of the things being compared. The comparison is expressed as a ratio and as a unitless number. By multiplying these ratios by 100 they can be expressed as percentages, so the terms percentage change, percent, age, difference, or relative percentage difference are also commonly used. The distinction between change and difference depends on whether or not one of the quantities being compared is considered a standard or reference or starting value. When this occurs, the term relative change is used and otherwise the term relative difference is preferred. Relative difference is often used as a quantitative indicator of quality assurance and quality control for repeated measurements where the outcomes are expected to be the same. A special case of percent change called percent error occurs in measuring situations where the reference value is the accepted or actual value and the value being compared to it is experimentally determined. Definitions: given two numerical quantities, x and y, their difference, I equals x, y, can be called their actual difference. When y is a reference value, then I is called their actual change. When there is no reference value, the sign of I has little meaning in the comparison of the two values, since it doesn't matter which of the two values is written first, so one often works with I equals x, y, the absolute difference instead of I, in these situations. Even when there is a reference value, if it doesn't matter whether the compared value is larger or smaller than the reference value, the absolute difference can be considered in place of the actual change. The absolute difference between two values is not always a good way to compare the numbers. For instance, the absolute difference of 1 between 6 and 5 is more significant than the same absolute difference between 100 million 1 and 100 million. We can adjust the comparison to take into account the size of the quantities involved, by defining, for positive values of x reference. The relative change is not defined if the reference value is 0. For values greater than the reference value, the relative change should be a positive number, and for values that are smaller, the relative change should be negative. The formula given above behaves in this way only if x reference is positive, and reverses this behavior if x reference is negative. For example, if we are calibrating a thermometer which reads -6 degrees Celsius when it should read -10 degrees Celsius, this formula for relative change gives /=4/-10 equals -0.4, yet the reading is too high. To fix this problem, we alter the definition of relative change so that it works correctly for all non-zero values of x reference. If the relationship of the value with respect to the reference value does not matter in a particular application, the absolute difference may be used in place of the actual change in the above formula to produce a value for the relative change which is always non-negative. Defining relative difference is not as easy as defining relative change, since there is no correct value to scale the absolute difference with. As a result, there are many options for how to define relative difference, and which one is used depends on what the comparison is being used for. In general, we can say that the absolute difference I is being scaled by some function of the values x and y, say f, x, y. As with relative change, the relative difference is undefined if f, x, y, is 0. Several common choices for the function f, x, y, would be max, max, min, min, x plus y, /2, and x plus y /2. Formulae: measures of relative difference are unitless numbers expressed as a fraction. Corresponding values of percent difference would be obtained by multiplying these values by 100. One way to define the relative difference of two numbers is to take their absolute difference divided by the maximum absolute value of the two numbers. If at least one of the values does not equal 0. This approach is especially useful when comparing floating point values in programming languages for equality with a certain tolerance. Another application is in the computation of approximation errors when the relative error of a measurement is required. Another way to define the relative difference of two numbers is to take their absolute difference divided by some functional value of the two numbers, for example, the absolute value of their arithmetic mean. This approach is often used when the two numbers reflect a change in some single underlying entity. A problem with the above approach arises when the functional value is 0. In this example, if x and y have the same magnitude but opposite sign, then which causes division by 0. So it may be better to replace the denominator with the average of the absolute values of x and y. Percent error is a special case of the percentage form of relative change calculated from the absolute change between the experimental and theoretical values, and dividing by the theoretical value. The terms experimental and theoretical used in the equation above are commonly replaced with similar terms. Other terms used for experimental could be measured, calculated, or actual, and another term used for theoretical could be accepted. Experimental value is what has been derived by use of calculation and/or measurement and is having its accuracy tested against the theoretical value, a value that is accepted by the scientific community or a value that could be seen as a goal for a successful result. Although it is common practice to use the absolute value version of relative change when discussing percent error, in some situations, it can be beneficial to remove the absolute values to provide more information about the result. Thus, if an experimental value is less than the theoretical value, the percent error will be negative. This negative result provides additional information about the experimental result. For example, experimentally calculating the speed of light and coming up with a negative percent error says that the experimental value is a velocity that is less than the speed of light. This is a big difference from getting a positive percent error, which means the experimental value is a velocity that is greater than the speed of light and is a newsworthy result. The percent error equation, when rewritten by removing the absolute values, becomes. It is important to note that the two values in the numerator do not commute. Therefore, it is vital to preserve the order as above, subtract the theoretical value from the experimental value and not vice versa. Percentage change. A percentage change is a way to express a change in a variable. It represents the relative change between the old value and the new one. For example, if a house is worth $100,000 today and the year after its value goes up to $110,000, the percentage change of its value can be expressed as. It can then be said that the worth of the house went up by 10%. More generally, if V1 represents the old value and V2 the new one. Some calculators directly support this via a %ch or I% function. When the variable in question is a percentage itself, it is better to talk about its change by using percentage points, to avoid confusion between relative difference and absolute difference. Example of percentages equals, if a bank were to raise the interest rate on a savings account from 3% to 4%, the statement that the interest rate was increased by 1% is ambiguous and should be avoided. The absolute change in this situation is 1 percentage point, but the relative change in the interest rate is. So, one should say either that the interest rate was increased by 1 percentage point, or that the interest rate was increased by. In general, the term percentage point, s, indicates an absolute change or difference of percentages, while the percent sign or the word percentage refers to the relative change or difference. Other change units, change in a quantity can also be expressed logarithmically using the unit of logarithmic change, the decibel and the neper. Normalization with a factor of 100, as done for percent, yields the derived unit centimper which aligns with the definition for percentage change for very small changes. But using CNP has two additional advantages. First, there is no need to keep track of which of the two quantities, V1 or V2, the change is expressed relative to, since, under the conditions of the approximation, the two quantities are nearly the same. Second, an XCNP change in a quantity following XCNP change returns that quantity to its original value. For example, if a quantity doubles, this corresponds to a 69 CNP change. When it halves again, it is a minus 69 CNP change. Examples. Comparisons equals, car M costs $50,000 and car L costs $40,000. We wish to compare these costs. With respect to car L, the absolute difference is $10,000 equals $50,000-$40,000. That is, car M costs $10,000 more than car L. The relative difference is. And we say that car M costs 25% more than car L. It is also common to express the comparison as a ratio, which in this example is. And we say that car M costs 125% of the cost of car L. In this example the cost of car L was considered the reference value, but we could have made the choice the other way and considered the cost of car M as the reference value. The absolute difference is now minus $10,000 equals $40,000-$50,000 since car L costs $10,000 less than car M. The relative difference is also negative since car L costs 20% less than car M. The ratio form of the comparison says that car L costs 80% of what car M costs. It is the use of the words of, and less more than that distinguish between ratios and relative differences. See also, approximation error, errors and residuals in statistics, relative standard deviation, decibel. Notes. References, Bennett, Jeffrey. Briggs, William, Using and Understanding Mathematics, A Quantitative Reasoning Approach, Boston, Pearson, ISBN 0-321-22773-5, Understanding Measurement and Graphing. North Carolina State University, August 20, 2008. Retrieved May 5, 2010. Percent difference % error. Illinois State University, Department of Physics, July 20, 2004. Retrieved May 5, 2010. External links: http www.acpenline.org Journals Publications Jan Feb 00/Primer HTM http books.google.com/ Books ?ID equal AY7LNIKLNKC ampersand LPG equal PA62 ampersand OTS equal _7SOZD _KTZ ampersand DQ equal %22 relative %20 difference %22 %20 %22 absolute %20 difference %22 ampersand PG equal PA61